Now, for the full code, if you happen to be a programmer, have interest in data science, or you are an embedded developer with a little bit of knowledge of Python, or either one of these two, you can use our full code AI development platform. It's entirely flexible. It gives you all the bells and whistles, makes you more productive with the tools we have on our website. And just to showcase you for the guys who are not aware of how the development goes, generally these models are developed on large machines. And we are bringing these models to smaller, tiny devices, and that requires a different kind of software stack. And this is what we are focused on. Our niche, our focus, our forte is those tiny devices. So we have developed everything from compiler to rest of the tools. And the development flow on bare metal devices or RTOS looks somewhat like this, where you start with the hardware, like we picked Arduino Nano in this case. You acquire the data, train the model, and analyze the model, validate and test. Once you're satisfied with the accuracy, then you go on compile the model and continue developing the app in the platform. And once you're satisfied with the entire application, you compile the application, you flash the app, and you monitor the device like we did in the last demo. And so we actually have automated 7 out of those 8 steps. Once you have chosen the board, you come with the board, plug it in our platform, and there you go. That's all you need to do. The rest of the tools and softwares are on our website, on our platform. And we have a differentiation of a compiler, deepC. This is a proprietary version. And we also have an open source version of that on GitHub, which is fairly popular, being used by several companies and users. You can check it out. If you Google AITS deepC, you can find the link to that repository. So it's an end-to-end platform, no setup needed, cross-compile, we have gallery, and like I said, it's as easy as bringing your board to the platform. It does the rest. And it is an end-to-end development, full stack, meaning you can connect the board, and based on the kind of board, we actually provide SDKs to acquire the data. And we support anomaly detection, audio, vision, and sensor fusion. And once we detect, or you tell us what kind of board is it, you can acquire the data in our platform, just like any other IoT dashboard. Once you have that, you can create a data set out of that. And this is for data sciencey kind of engineers and programmers who have that knowledge. And you can create the data set. Once you have the data set, we provide all the frameworks in our platform, starting from TensorFlow and PyTorch and keras. And once you have that, once you have trained and tested your model, you save the model and we support all kind of formats, including TensorFlow, PyTorch, keras, Onyx, Caffe. And once you have saved the model, the next step is to compile the app. And we actually provide a couple of tools. One is our own that we developed, and we compete with TF-Lite Micro, which happens to be an interpreter. Ours is an ahead of time compiler. So by comparison, we save you quite a few CPU cycles, and we are better on RAM and flash size. But for whatever reason you happen to like TF-Lite Micro, we have given you that access as well. And we are not tying you to our version. If TF-Lite is better, let the better product win. And so we give you the access to TF-Lite Micro. And once you are done with that, you compile that to the microcontroller of your choice. Any Cortex-M series type of IP with the board from ST or Arduino or NXP or whoever have you, you can download the app and flash it. So these are the 4 steps, and here I showed the formats and frameworks. Now, how does that tie to our platform is on this screen. You acquire the data. We have a feature called palette, which lets you upload the entire data set. You can upload image, you can record audio, you can record video, and you can also register your device with other sensors. This is the latest feature. If you go on our website, you will find another one where it says sensor data. You can either use HTTP or MQTT protocols to directly record your data. So we give you everything to acquire the data. And once you have, then for training the model, there is an open notebook server that you can start with a powerful machine with GPU running in the background, which typically lets you train any type of model which is, reasonable enough that can be brought to a microcontroller within 20 minutes. And also the gallery and the compiler. The next step is compiler, and we provide compiler, whereby either you have it in the project or you can upload the model and we would compile it, and finally you download and flash. And so these are some of the features that I'm going to show you in few slides, and then we will go to the demo where I will showcase the how to develop the model in the PyTorch and compile it to the model of your choice, or the microcontroller of your choice. So we have Python and C++ notebooks integrated in the platform. And on practically every screen, you will see the compile button, be it in the notebook, or there is a standalone screen or dialog you can see where you can upload the file and compile it if you're just into the compiler. Or for every model that we have on our website, there is a corresponding article that you can go read and find out what this is, what kind of data set it takes, how to modify that, and how to work with it. And if you have questions, you can always reach out to us. So, Python and C++ notebooks, compiler and articles, and you can also clone and share if you have. If your work is open source, you can bring it to our platform by simply typing, copying and pasting the URI of the repository. And with that, let me go on to the full code demo. And here, I would showcase how would a programmer will use the platform. So this is, you go onto the dashboard. Once you log in, you typically are taken to the dashboard where you click this, and that starts this notebook server. And there you can either bring the notebook from outside, or you can start developing your own. And these are the, here, if you click, it will let you, select the preferred kernels. And like I said, we support Python and C++, flavors of C++. In this case, this is a Python notebook, and the application we are developing is American Sign Language. And the data set is collected with the gyroscope. It's the same board that I used before. Earlier, it was using microphone. Now it is using accelerometer and gyroscope to collect the data. And for those of you who are not aware what American Sign Language is, what are the signs, how, and what's up or how are you is, this is how mute people say hi. And this is how are you. So we have taken a couple of those gestures and created the notebook, in particular, hi and how are you. This is what we are collecting the data on, and this is all using PyTorch. So if you're interested to, get access to this notebook, feel free to log on to our server, and it will show you. It'll show you the ASL training, and you can just clone it in your user space and start with it. So what we have is we have already collected the data set in hi.csv and sub.csv. Now the next two sections will be, it's basically, displaying the hi gestures for accelerometer and gyroscope. This is accelerometer, and this is also accelerometer for SUP, and this is gyroscope for hi, and this is gyroscope for SUP. And this is your network. I'm not going to go into the details of that network. If you're curious, go ahead and log on and find for yourself And this is how you train the model. It's a very small and simple model using ReLU and fully connected layers. And this is where the training happens. And if you see, this was already trained. The loss in this continues to goes down. That's what a data scientist would look for. The accuracy should be close to 100% or 90+%, depending on your expectation and the data set size. And once you're satisfied with that, you go ahead and evaluate. And in this case, our test accuracy is also 100%. So once you're done with in training this model in the notebook, you save it. And in this case, we are using PyTorch and develop that in PyTorch. PyTorch has a feature to export the model in Onyx. And this is what the Onyx graph looks like for this particular application. Now, for this model, once you have the Onyx model, now comes to the compilation part, which is as easy as showing a command of deepC. deepC is a command for our deepC compiler, and you give it the Onyx model. By default, it will compile it to the Linux version that the server is running on. If you want, there are other options specifically designed and coded for boards that we support, including Arduino Nano, ST, and some of the other boards. So you can simply say board and provide the board name, in this case Arduino Nano or whatever. I'm not going to do that. In this case, what you see is this is compiling and also optimizing it for the underlying machine. And final binary size you can see is about 167 kilobytes. And you can run that. The advantage of using this another advantage of using this is you can debug and make everything ready on Linux for the developers who are comfortable with Linux more than the bare metal. And once you are satisfied, you can add another switch for the microcontroller of your choice, and it'll cross-compile for that particular board, and you're done. Now, this is just a model. So what we also provide as an intermediate code step is access to C++ code depending on your license. And this is how you convert the model, Onyx model, to a C++ code, and which is available right here. I am not going to go through this, but if you are curious, we can talk about the entire process. And this is typically where app developer will take this model and continue to develop in the platform itself with writing additional glue code that makes the application entire application complete. And once you're done, you just hit compile and download the application as binary. So this was our full code demo.